Hello, everyone, and thanks for being here. We are here very happy to have Emile for this Talking Robotics session. So I'm happy today to introduce Emile. Emile has been working on social robotics since 2013 in 4 different companies, now RoboHearts, which he just founded, making application and teaching others how to make good robot application. He has also worked as a game designer, a game programmer, a university lecturer, has given training sessions and talks on robotics and AI, workshop for kids and students of all ages, and run cutting-edge robot demos on live TV. So I'm gonna give the floor to Emile.
Thank you, Sylvia. So I'm going to share my screen, I guess. So hello, everybody. Thanks for the intro. I have a brief slide saying about the same thing, so I'm going to skip it. And so, yeah, my topic for today. So thanks a lot for this invitation because it really allows me to talk about what I like talking about. So both on the technical stuff, but also on the more like broader picture of where do robots fit in all this stuff. And by the way, I'm here with Pepper is with me, running our app actually, but I'm not going to do any live demo. That's going to be a bit too risky. I also have my Now down with me. But basically, what I wanted to talk about here is there's a lot of really cool stuff like on Twitter, on YouTube, on LinkedIn. Everybody has really cool robot demos. There's a lot of labs working on stuff. But of course, not much of this gets deployed in the real world. And I want to basically recount a bit of my experience with real world deployment. So I'm not really an academic. I'm more of somebody who takes cool stuff other people build and helps integrate it into real robot that's going to work with actual clients that pay us money, often a valuable feature. And so go over like some of the difficulties, some of the interesting points that go around this. And I have 3 rough categories on the kind of challenges you can run into when doing this. First is going to be the market challenges. So this is getting product market fit, basically. Okay, it's nice to have a cool robot demo, cool idea, but is it actually solving a need? And is this a need that people are willing to pay money for? The other one is like the core interesting one for human robot interaction is okay, actually creating an good interaction with a robot is pretty difficult. There's a lot of hard points, and that's what makes it a very good topic for study. And that's what a lot of people here are interested about. And the other one is actually there's a bunch of like boring fiddly details. You won't get a PhD around those, but it's really good. It's really like challenging to go from like a one-shot demo of a robot doing something to a robot doing it on the field without having a human supervising it. And there's a bunch of like fiddly little details and anecdotes to go over there. But first, market challenges. So the common question is, okay, how do we make robots that are actually useful in the real world? But this is not exactly the question I want to talk about. It's more of it's not really a good question because the question is, why do we even care about robots as a category? Like, what's special about the word robot? It's just a kind of automation. There's a bunch of stuff you could do. You don't really need a robot to do it, even though a lot of people are trying to do it with robots. But you don't always need a robot, and especially you don't always need a humanoid, a human-looking robot. If you want a cleaning robot in your home, which is a kind of use cases a lot of people show with humanoids, you can do it with a Roomba. It will maybe do 90% of the job for 1% of the cost. So why is robot a category? And I think in my thesis is basically that a lot of this is about the actual word robot, because robots are really cool. They're all over the place in popular culture. A lot of people love robots and they love the idea of robots. So like in theory, like a robot arm in a factory, this is going to be called a robot. This is what you study when you're doing robotics, but this isn't really what kids expect when you tell them about a robot. They expect something like this. So the archetypal robot. A lot of talk about humanoids is about this. And I've seen it used for robots that don't have legs, that don't even try to look human, but they don't look human, but they look like a robot. So a social robot is a good term for that. Generally the one I prefer talking about social robots, but basically the way I put it, it's a robot whose job is to be a robot. And that's a bit self-centered, but there's a common idea of a robot, so that's perfectly fine actually. one problem with this is that people find robots so cool is that they will build a robot and then they will ask, okay, what can I do with this robot? And they will put out a bunch of use cases that you could actually conceivably do with a robot. And you have a lot of hype around this, around humanoids, and showing what you could do with humanoids. And like, okay, so anything a human can do, a humanoid could potentially do. So you can come up with arguments about big numbers on this. But I think this is kind of misguided. For a lot of things, really, a humanoid doesn't really make sense, or a cool looking robot doesn't need to make sense. So does this mean that cool robots have no use, that we should focus on, if we're going to focus on use cases and something with business, does that mean we need to start from the pain point and design a robot around that, which is how you get a dishwasher instead of humanoid washing dishes? Well, not really. I think that the fact that robots are cool is not just about fluff. It is fluff in terms of it will attract a lot of attention, much more than if you just have a machine doing the same thing. So you have a dishwasher, nobody's gonna be excited. You have a robot washing dishes, you're gonna get publicity, people are gonna talk about you, you're gonna get investor money, people are gonna want to work for you, because a lot of people love robots and robots are really neat. So, but does this make it a viable business model? Because the trap you can kind of get is you have a nice story to tell about robots, you have a really sexy demo, you have a bunch of investors getting into this, or a bunch of like researchers doing research about this, but in the end, you don't really deliver a robot that's actually capable of providing value in the real world. So you can have a company that's going to work, but not for super long. So it's not enough to just be cool, or wait, it can be enough to just be cool, but you have to have a clear idea of what you want. So here's a bit of a map of the kind of things you can do that are not just about physical tasks. So yes, physical tasks, that is something that you could do things with, but that's not going to be enough to justify like the extra cost and complexity of a cool looking robot, of a humanoid robot. I don't really like the term humanoid that much because it's kind of supposing that the answer is it needs to have a humanoid shape, and humanoid shapes are cool. A lot of the examples I give are humanoid, but you can have a social robot that's clearly a robot that looks like a robot as a kid would imagine, but it's not humanoid. It could have wheels, it can have a screen for a face, etc. But so here are a bunch of other, so 3 other ways of providing value. So looking cool, research and education, and social interaction, which is probably the deepest one here. So looking cool actually in itself is value. Like if you look at a really fancy hotel, you might have a statue in the welcome area. That statue is not providing any value either. It's not giving useful information to guests. It's more of a prestige thing. And that's actually a reason why a lot of people will get a social robot in their place. They want to give an image, well, not of being wealthy, but of being like high-tech and savvy. And a robot is a great way of doing that. Even if the robot is not actually useful for anything, it's gonna like carry people's luggages, but still you have a robot in your hotel. You're a pretty classy hotel. Another one is the one you have at the image top here is just doing shows, entertainment. And actually this is where you're not going to design a machine for entertainment. That's a TV. The fact that it's actually a robot with an interesting shape, so typically a humanoid robot, but not only, is going to bring a lot of value. And that's and the example here was a live TV show with 20 dancing robots, which was, of course, a very interesting technical challenge and a lot of fun to do. And the entertainment is a good one, but also, unfortunately, this market is a bit limited. In that once the novelty is over, then you're not going to like keep buying new humanoid robots for this. So this is an area that exists, but is kind of niche and it might not scale. Another thing also attracting people into businesses, this is what got Pepper Robot off the ground, is that we have a robot, we're going to put it in our store, and a lot of people are just going to come in. The use case I worked here was for Uniqlo. We made a robot that would give information, so it was useful. It knew about the clothes you could get, it could show you where to get them. But the main value from the store's point of view wasn't that the robot is like going to replace an employee at being useful. The main point was you have a robot in the store, people are going to be curious and come in and talk about it. The usefulness of the robot is almost kind of a pretext for justifying putting a robot there, but the main value is just having a robot. Another use case is research and education, and this is, of course, like a huge area. And here it doesn't really matter if the robot is not tailored to a use case, because that's what makes it interesting. So, for example, legs. Legs are like, from a locomotion point of view, in a huge amount of areas, you don't really need legs. They're not a great design. Wheels just work much better. You don't have like cars with legs. But still, there's a very interesting technical challenge. That means that it's good for research. It's good for learning to tackle hard technical tasks. You have the RoboCup, which is about humanoid robots kicking balls around. You need legs to kick balls around. So the fact that these robots are not optimized for use case works perfectly fine. And of course, also in education, you want to get people interested in this. And a robot is just much better at getting kids' attention than others. And this is like a very valid use case. Another one, so social interaction is the one I'm the most interesting, is going beyond just, hey, it's a robot, it's cool, look, it's a robot. It's the robot is actually doing something useful. It doesn't need to be with your hands. You can have robots talking to people. So, of course, giving information is a useful one. And this is especially useful when the information can be multilingual. And that's a case where Pepper has been useful around the world, in that you've had robots in public places. So the robot might not be better at giving information than a human. However, the fact just that a robot can do this in many languages is a big gain. The fact that a robot can do this all day, like in the evening in an airport when like there's much less staff. It can do like simple processes like, information for check-in, check-out, validation, etc. Another very common one is conversation practice. You can talk to a robot and like you can practice negotiation with a robot. You can practice like we have there are uses with autistic children, like getting used to talking to a robot. You can practice, of course, speaking a foreign language with a robot. And here a lot of value is just talking to a robot. And of course, like have a kind of companion robot in elderly homes, etc. is useful and is more of a social role. So RoboHearts AI is basically our company's main focus these days, is built around this social interaction. So the idea is to bring LLMs into robots for doing social interaction. So I can cover a few of the more successful use cases we have with this. And even though RoboHearts is kind of new, we've been doing this kind of stuff under other companies in the past, under the same kind of use cases. So, for example, the kind of use cases we have now, one, for example, is for research, having robots that people are doing like human-robot interaction research and want to have a robot people can just come and talk to and vary the conditions and get information on how that is going. And as robots can be expected to take more role, studying how people relate to robot is, of course, very important. Another one is in technical school. So they use a robot for a lot of different things. This one is shown in a bit of an ambassador or mascot. This is shown in some glass working event where they bring the robot where they brought the robot with them to demonstrate they had built this, glass. The thing on the arms are built by the students, but they also use the robot for conversation practice. For example, they're training nurses and the robot is going to pretend to be an elderly patient with dementia, or they're training security guards and the robot can pretend to be a problematic customer in a store. So you can have a bunch of real situations to practice into, in addition to the more normal use case of learning programming, introduction to AI and all that. And doing this with a robot makes it a bit more like stress-free and easy to do in various situations. Another one is like a welcome robot in science museums. So we have one in Pepper. We also had it with Now in Germany, but have just a demo of a robot doing interaction, greeting people, showing directions. One interesting way to do it, one metaphor that we like is having the robot be a character. So you can just edit the character, define the robot's role, and with the LLMs, this makes it easy to have a robot that can take on various roles. And I also kind of like this kind of use cases because we're moving away from screens and more into real world interaction, and in an interaction that's a bit more natural to humans than like dealing with a touchscreen or dealing with your smartphone. So kind of to recap this section on why we care about robots, the answer is that being a robot is actually a useful job. You just have to be clear about what its job is, and not try to think of use cases that don't necessarily make sense. So on to the other section. So interaction challenges. So this is, well, interacting with robots is hard. Making a robot that can interact with people is hard. Humans are kind of good at it, though. Even like a bunch of situational comedy is about failures of communication. And when we talk to people, there are actually a lot of like misunderstandings, etc., to deal with. But we're practicing this since we're little kids, so we're very good at dealing with it. But once you want to carry this into a robot, you have to really understand all the little details about this. Like one difficulty is, of course, the real world is a huge mess. If you look at robot demos in like on YouTube, you'll see like there's one person talking a robot. In the real world, you want to put a robot, the environment is going to be a huge mess. A lot of things going on in the background. Specifically, perception is difficult. For example, here, can you guess what the problem is? The problem is this little sign on the left here with the advertisement. The robot thinks it's a human and will turn around and talk to it. And when we deployed this robot on the field, this was not an issue because they didn't have that advertisement yet. So all the tests worked fine. And then we go away. And then they change the advertisement and the robot turns around and stands there waiting for the human to talk to it. The sign never talked to the robot. And you have a bunch of like situations going like that all the time. So one more specific case study, the use case is integrated LLM into robots. So this is what we did for RoboHearts. What kind of issues will you encounter dealing with this? Because if you analyze situation, ChatGPT has it really easy because what the user types into the text field is exactly what the LLM will get. So that means the user wants to say something and he types exactly what he says. But in the real world, well, you say something and what the speech recognition is going to understand might get it wrong. Typically because people like, if you actually look at how people speak, even like what I'm doing now, they will interrupt themselves all the time. They will say etc. The sentence is really completely a mess if you like transcribe what people are saying, and the robot has to deal with this. People don't speak the same way they type. When you type, you're going to make clean sentences. When you speak, it's a real mess. If you make a mistake, you can't self-correct the way you would when you type. And of course, you have like people with a foreign accent or that are just old or very young and have a difficult voice. So this is going to add a lot of noise. Though in practice with LLMs, they handle this much better. So that makes these kind of use cases easier to build than they were like 5 years ago. Another difficulty is the context. Like maybe the person wasn't talking to the robot at all. You're going to have a robot in a public area, and this is not a nice scripted scenario in a lab. This is a case where the robot is just hearing whatever goes by. So you have to deal with humans, just noise coming around. Another common difficulty is crowds. You have a lot of people around. One is talking to the robot. The robot might not even be looking in the right directions. Several people talking at the same time. This is hard to deal with when you're one person, but to program a robot that can deal with this, it's even harder. And that's a bit of overview of the kind of difficulties you have for interaction. I'm checking my time here. I have like 10 minutes left. Is that it?
You still have some time, yes, no
Oh
worries.
yeah, okay. Maybe I went a bit quicker than I expected.
That's fine. There is more time for chatting if you want
Yeah,
to.
that sounds good. I was afraid I have 45 slides. So finally, boring challenges is all the other stuff you need to get right. Because okay, it's nice to have a core interaction, but you have all these other aspects that are going to you have to deal with, and that this is well, you're not going to get a PhD for that. You get a PhD for the nice, interesting topics of the robot interaction or overcoming a really hard technical challenge or dealing with an interesting use case. But there's a bunch of like situations that's going to really make the difference between something that's a one-off prototype, a one-off demo, versus an actual product on the market. And so the obvious one kind of is mass production is hard. So a lot of robots that you might see on YouTube, the demos, they're built one by a team of engineers. And if you want a new one, you have to order it. It's going to wait 6 months and costs hundreds of thousands of dollars. And you might not realize this when seeing the demo. You expect, oh, this is a product that I might get in a shop tomorrow. But the distance between a prototype and something that's actually being like mass produced on the market is huge. I think it was Elon Musk was saying that the challenge isn't building the car, it's building the factory that builds the car, and in a way that you can keep costs down. So that's something that often that means that you might underestimate to which extent a specific project is actually ready to being used. One difficulty we often run into is safety, physical safety. So what if the robot falls over? That's a huge issue with a lot of the humanoids you see today, which is why I don't really expect to see them interacting with real people in the wild. And that basically, physically, if the robot falls over and hurts somebody, this is going to be a huge liability issue. And this is the kind of stuff that can really kill a project for good. Like if your robot doesn't hear people very well, all people are going to retry or be a bit disappointed. If the robot kills a child, that's often considered bad publicity. And anybody deploying a robot or selling a robot wants to make sure that has no chances of happening. For Pepper, in the initial versions of Pepper, we had to always have a harness. It was attached to the ceiling with a cable. And we didn't actually believe the robot would be able to stand up permanently all the time. In the end, it was capable of doing that. For now, so now robot. One issue this robot always had is that, so it's nice, it looks very cool, but you can pinch yourself in various places, especially around the legs, quite hard. And this basically is a very difficult problem to solve, and you need to redesign a lot of parts of the robot to solve it for good. And this is why this has limited the sales of robots. That means the robot has to be sold to institutions, research that are a bit more tolerant in terms of how they handle the robot. But if you would not be able to sell it in a supermarket, for example, for these kinds of reasons. And with the recent range of humanoids, this problem is even bigger because they tend to be as tall as humans and made of metal, which is much worse than Pepper. Pepper once fell on my kid, but that was okay. Pepper wasn't damaged. So another challenge, actually, this one is also a huge pain that you get every time you do something with a robot, is dealing with the network. Anytime you want to, and this is especially true for the first time you're in a specific place, but when you're doing a show or an event, that's basically the only moment you're going to be there. You're there for one day, you're going to have one day of dealing with the network. And there's going to be a bunch of constraints. All kinds of places have weird network setups, like often academic places, you have to go through the special, what's it, EduConnect, something like that.
Moodle? No?
No, there's this EduRoam. EduRoam, right. There's this whole EduRoam thing that all the academic laptops are connected to, but your default robot, you have to jump through a bunch of hoops. And this is for any kind of device you want to set up in these areas. And then hotels are going to have their own special networks. You're going to be in events and shows, and they're going to have these sometimes either like every single stand has its own network and they all interfere, or the event organizers themselves, they set up the network scramblers that prevent you from using the network. And this can mean basically nothing can work. And this problem becomes doubled if you're actually selling a solution to a client and he's going to be the one setting up the network. And that's where you have to make sure that the user experience is super smooth. And for example, the image here is when I had to do a talk show in Germany on live TV with a Pepper with ChatGPT. So that means you need a network connection. It's going to need to be quite good. And in the end, it worked. But like half an hour before the show was starting, we were still not sure of being able to have a sufficiently good network. So another common challenge is wear and tear. A lot of these cool robots, humanoid robots, social robots, are physically quite complex. They're not just one big screen. That means the more moving parts you have, the more parts can break. This has been an issue with Pepper. Like kids love playing with the fingers, and if you don't watch them, they will play with the fingers and break the fingers and take a piece of finger home. And actually, kids are really dangerous. Kids are the worst, because especially groups of kids, because they want to impress the other kids. So they're gonna like try to outmaneuver each one at who can do the more outrageous things to the robot. Sometimes the high five and fist bump animations are extremely popular with the public. They're not popular with the repair team. So there's often the debate of, do we want to have a robot that's going to be touching people a lot, which is very popular, or do we want to make sure that the robot never breaks? And again, this is the kind of thing that when you're dealing with a custom prototype, you can just adjust everything. If you want a mass-produced project, you're going to have to think of life cycle. Another issue is special accessories. I've worked with academic projects. So this case was El Tutor, but or partners who want to do something with the robot, but they're going to add a bunch of extra accessories to it. So they're going to do a speech recognition solution, but there's an external microphone that you need to talk to, and adding all kinds of these stuff, it will prevent it. Again, you can make a nice demo. It's going to work maybe better than what you could do with just a robot, but it will not be able to scale. And in this case, I was a bit annoyed because the academics were insisting on using like an external Kinect for doing some detection, even though technically the robot could do the same thing as well. But they had no concern for how scalable this would be. And this was a bit of a pity, because this was an actual education project for children. So the academics were interested in like having set up where they could collect data for analysis and publication, but all the extra setup means that this solution become much more expensive and could not scale. Like the complexity of setting it up, connecting everything, etc., meant that this had no chances of like a random school being able to deploy this solution for a robot. And how are we time-wise?
I think, depending on the question, if you want, you can still have 5 minutes.
I'm gonna like list a few other challenges that don't have their own like super side, but so data privacy also a huge issue. Earlier I was talking about like the robot falling over. That's like a safety issue, but another one is data privacy. There's also huge regulations on information, and people have very contradictory expectations about this. And they will expect that the robot can recognize them, but also they want the robot to never save any data about their face or any biometric data. So for a human, that makes sense. Yeah, the human's going to recognize you. I'm not going to like secretly save your picture somewhere. But the way the robot works, technically, the robot is a server, and all those issues, if you read the law as written, you might run into issues that mean you have to have a sign next to the robot saying, be sure this or that. And GDPR specifically, like a lot of engineers have complained about GDPR because the law was written with some idea in mind of how technology might be used. But once you start applying to all the edge cases, and robot is really an edge case, it doesn't make sense. Like technically, the voice of a person could be considered biometric data, even though like the robot is never saving it. So that's kind of issue. UX, I didn't mention this, but this is a huge one. You need to make sure all part of the user experience is nice. So earlier I talked about the human-robot interaction, so that's basically about UX. But also there's all the stuff about the setup. I was mentioning the network, but like updating, making sure you can run the application, etc. There's a bunch of little things that can really be the difference between you have to have like an engineer from the company setting up your robot versus you can just ship a package over to like Poland and they just open it, turn it on, and the robot works. And this is really a huge area with a lot of subfield, but UX is its own field. Another one in information security. So basically, this can go a bunch of different ways, but this has been especially an issue when we're dealing with a client who is going to be like a bank or insurance company, and they tend to be very paranoid about installing a device inside their company network that could access things, or that has microphones that are on all the time. This is really something that they will be very paranoid about. Also, there might be the question of, can somebody hack the robot, get access to it? So you have some robots where somebody could just go up and start touching the screen and launching random things, take photos of themselves, record themselves, etc. There's a bunch of like stuff that can you need to prove that the system is kind of like hack proof, which usually is almost the opposite of making a system that's easy to use for academics. So when it's like in academia or in a demo, you want a system that's very open. You can do what you want with it. When you're going to deploy it on the field, you want to close all that and make sure it's ultra secure. And that's mostly my overview of a light little tour of some broad families of challenges you can have with robots. So to recap a bit, one challenge is, yeah, having a good use case. And for that, like, since we're talking about social robots, the one I'm more interested in is robots whose job is to be a robot. And there's some good use cases to be built around that. Interaction challenges. So human-human interaction is hard, but human-robot interaction is much harder, but also a very interesting field. And then there's all the boring stuff that's not really interested. You don't really like reading the GDPR law or making sure that your network connection handles weird things. But you also have to deal with it if you want to have a product that can actually be shipped. And that's it. Thank you, everybody.
Thank you, Emile. Is there any question?
Or comment or criticism or insults.
Yeah. If there is no, I will start with the first one. And then it'll take, if someone wants to ask a question, you can also write it
I see
in
there's
chat.
something in the chat, but how can I open the chat? Wait a minute.
There is also Nitin who is gonna,
okay,
he just raised his hand. So you talked about the fact that the robot itself creates some novelty effect that suffice for the robot to be there and to justify its use. But what about repeated use, a repeated exposition? Like, would it still be something
often not really. That's an issue. That's where you might have and this was kind of the issue with Pepper, though, in that a lot of cases, like, people would just buy a Pepper and just have it as an attention getter, but not really have any plan for any long-term value with it. And and those kind of use cases kind of lost their value after a bit of time. But yes, that's an issue, and that's what kind of makes this the whole. If I go back in my slides, wait, let's focus. If I go back to my sorry, this looking cool aspect, this is the one that it's kind of the easiest to do because all you have to do is build a cool looking robot. And actually, it's a bit surprising because not many people do that. A lot of, like, after Pepper and now that are getting kind of old, a lot of other robots are like super ugly. And I don't like, I was at a fair in China and there were all kinds of like humanoid-ish robots that can be compared to Pepper. They were all uglier than each other. And the kind of exception I would say is Miroki here on the left. Or I'm not sure if that's Miroki or Mirokai, but he's actually very well designed, which is maybe not a coincidence because he's made by Jérôme Monceau, who also had a huge input on Pepper. But yeah, looking cool is okay. You can make a robot that looks cool. You can make a cool demo, but if you don't provide long-term value for this, then it's not necessarily gonna last. I mean, for a sufficiently cool robot, it could work. If it's not just a novelty, but actually the design itself is good, the robot has some great animations, etc., you can keep surfing on that.
Okay. There are two questions. There is Nitin and Andrew that would like to ask questions.
I'll go ahead, Nitin. I think you.
Yeah. Thanks for the talk. I think one of the questions I had was about a few topics you mentioned about security and privacy. So, considering what you work on in RoboHearts and previously, I can imagine data from real world being very useful to go make improvements to the system. How have you been able to navigate some of the difficulties which come? One is by connecting a robot to internet, like the infrastructure side of it, and also from the customer side of it. Like, have you faced a lot of reluctance from people who buy these tools and services?
Sometimes, yes.
Right.
I mean, there's been quite a few different situations, but basically, we don't really collect like deep interaction data. Like, we're not going to connect any dialogues, or like we can, but those would be like when are doing our own testing. But we're not going to collect like all the logs of everybody who talks to the robot, because that would be a huge GDPR issue, actually. So unfortunately, even though this would be very useful data to train on, we don't want our robots are not there to spy for us. And usually there are some cases where some researchers are interested in getting access to that data, but we have to make sure that, and we've had that working, but in a way where the researcher has access, but we don't. So it's only stored on the robot, and we don't have access to it.
I see.
And yeah, for privacy control, so there has been controls, but it's more almost at the like rubber stamping stage of it. So it's not that people are actually concerned about their privacy. It's more about the person approving a specific project wants to make sure that there's not going to be any privacy issues with this. So that's going to usually be either to do like make sure that the human starts the interaction and he is aware that he might be recorded, or there's this informative sign, etc.
I see. And if you really wanted those, could you be doing something like a beta test where you?
Oh, sure. Yes. Yeah.
Okay, that makes sense.
Yeah. We like when we're dealing with our own tests, we get the logs, and I have some logs of that stuff. But yeah, that's definitely a different situation.
I see. Thank you.
Thank
Andrew?
you.
Thank you, Emile. Great talk. It was. I love your characterization of a robot whose job is to be a robot. That's something that I've been sympathetic to for a long time, and it was great seeing, you know, a lot of the applications that. It was a trip down memory lane.
Yeah, exactly.
I'm wearing a Now T-shirt. So I'm sympathetic, obviously, because a lot of my career has been in socially interactive robots. But these days, when people ask me about that, what I say is that one of my main lessons from my experiences is that physical use cases are really important. I think that embodiment is really valuable for social interaction, but that social interaction by itself is not sufficient to usually to justify the cost and complexity of a robot. Do you disagree? please prove me wrong, because I'd actually like to be wrong. But my experience has suggested to me that that it's very difficult to make a scalable value proposition without a good answer to a good physical use case answer to why do this with a robot.
I don't entirely disagree. However, so when it comes to physical tasks, I think at the current level of technology, it makes sense to almost say, you could say, okay, robots doing physical tasks on one side and social robots on the other, and they don't necessarily need to mix. And one reason of that actually can be the safety issue, is that often there's going to be a trade-off between how safe a robot is and how much physical, like typically how much can it lift, or how much strength does it have. That's a good thing about Pepper or Now, is that with their arms, they're incapable of like doing any serious harm to anybody. The worst they can do is fall over somebody, and you might get bruised, but that's about it. Whereas like the new range of humanoids over there, they're kind of scary. Like, I don't know if you've been with them in person, but even Romeo was kind of scary if you're up close and he's actually moving. And he was shorter than these humanoids and covered in plastic. But so I think that the physical strength aspect is going to be like a kind of a hard limit that's going to be hard to overcome between those two use cases. I did want to have a slide. I didn't want to have too much content, but about robots actually doing physical things, especially for education, is pretty important. And we have a bunch of stuff with Now. You might not see it very well here, but for this photo here was a workshop I ran in the RoboCup, where you were creating movements with the robot and then have the AI decide to do them. So, and this is an aspect of AI I haven't really covered here because I was on social robot, but the LLMs is not just about conversation. You can have the robot do physical actions. And this is an interesting bridge to gap, like navigate around, etc. But I do agree that physical robots are pretty useful and pretty important. I just wouldn't necessarily want to make them humanoid. Like you can build a mobile manipulator, and you can make them social. However, like they don't like you can. Social is not a great term actually, but you can like put a screen. You can say you can talk to it. You can get a voice command. I had a demo of I put a robot in a factory that was doing logistics, like carrying stuff around. But I did do an LLM integration that wasn't deployed in the factory, but you could like talk to it and ask it to go places or ask what it was doing, etc. And I think this conversation aspect, it's useful to build it with social robots, but that's something we might want to bring to other robots. But a robot's designed around a specific task, and the interaction is like an extra layer. But it's not you don't start from like a humanoid shape or a cool looking shape and then try to make it do physical stuff. That's kind of the part I'm the most skeptical about. But you could.
Thank you, Emile. We have also a question from Marine in the chat. Marine, do you want to ask or should I ask?
I don't have.
I don't know if, yeah, I don't know if she can talk because. So maybe I'm gonna read
Marine,
it.
yes. So very cool talk. You speak about robots that are made to be robots. There are a lot of different robots meeting this definition. Naomi, Rokai, Paro, Buddy, maybe Spot, and more. What are the must-have for these robots in terms of form factor and functionalities? Humanoid sensor. So this is mostly about this slide, where I kind of deliberately avoided giving a definition of what this is because it's kind of like you know it when you see it. And even humanoid, like you'd think there's a definition, but you know those cool little duck-like robots by NVIDIA and Disney. I've seen those called humanoids, even though they're, apart from the fact that they have 2 legs, they don't look anything like a human. They don't have arms. Their head is all flat. They've been called humanoids, and there's not really a good answer. I wouldn't say there's one form factor because you can be very creative. And this is a good example of all the really different form factors that have been used in fiction for more or less robots with a personality, which robots that are interesting to interact with. And well, apart from the one on the far left, that the weighted companion cube, this is almost an opportunity to be very creative. And this is something animators and artists can be good at, is designing a really cool robot that's that doesn't look like anything you would expect. Like the one on the top left is maybe the one that's pushing the envelope the most here. But yeah, the only limit is going to be what kind of expressivity you can have, and that can work with almost any form factor. However, I'd say the more movement and the more movement you can have, the better it is, even if that movement is in kind of unintuitive places. Like there's been some examples of animators. I think it was Ken Perlin, who had a great series of videos where he was just animating like a little rectangle walking around with various body language. And you really don't need anything apart from like a couple servos to just have something expressive.
Thank you, Emile. Is there any other question you're curious about?
Or people who disagree and want to debate.
Hi, I have a question. Can you tell us a little bit more about RoboHearts? I kept seeing that. I also came in a bit late, so.
Oh yeah, well, RoboHearts is basically my company, or like I started with a couple of colleagues, but we're making kind of like a solution for conversational robots. So especially for now in Pepper, but we also have prototypes with other robots. The idea is that you can just easily like define your character using LLMs or not. Mostly using LLM is the most interesting, but you just define in a few sentences, hey, you're a welcome robot. You're a very rude robot that refuses everything and finds a funny excuse every time. And that's always a fun one to write because you just do it in a few sentences. And then you have a robot that acts like that. So basically, we're kind of adding all the HRI layer around that to make sure that the interaction is actually smooth and all the fiddly things to make it work well and have more than just a chatbot, but actually an expressive robot that can like stand around all day.
Awesome, that's so cool. I recently I was studying human robot interaction in a PhD, and my thesis was on clothing for robots and like adding different personalities, like making the robot fit into different environments, like with different clothes. So it sounds like you're doing that. Like
yeah, that's one aspect I really like a lot is the clothes. It's a great way of giving some personality to the robot. Like when I was working at Aldebaran Salt Bank, they were discouraging us from putting clothes on the robot. Like the marketing would say you never need to do that. A bunch of Japanese people were doing it all the time, and sometimes were ridiculous, but I think it's a great thing.
Cool. I mean, it's much easier to write software for the robot to change personality than to like sew clothes every time. That's like
Yeah, but you have to think of the whole design.
Mm-hmm.
And you think, you know, OBOT, OHBOT, it's like a little education robot. They're
Mhm.
pretty neat. They have a lot. It's like basically a little head, like a very cheap version of the. I don't remember the name off the top of my head, but the fur hat robot.
Okay.
It's like a little $200 little blue animated head, but they have a lot of like accessories you can put on top of it to take on different persona.
Mm-hmm.
And I think that like it's easy to focus on the software and the cool deep learning demos, etc. But I think that just the context of the robot, what kind of person is a important factor to play with.
I agree. Thanks.
So you're preaching to the choir.
Great. Anyone else that would like to add something?
Actually, the clothes thing, did I skip a
I think
slide?
there's a question in the chat, Sylvia.
Yeah, maybe I can ask a question.
Super.
I just wrote it to the chat. First of all, thank you, Emile, for the great talk. In my experience, it is sometimes unclear for people dealing with a robot, and when they have no special experience with robots, and they overestimate the possibilities and the abilities of the robot, and then they sometimes are disappointed when they realize that it's not that good, that the robot is not answering correctly or it can't understand them.
Mm-hmm.
How do you deal in practice with these topics, this problem?
Managing expectations. I mean, well, I mean, one is not trying to do things that the robot obviously cannot do. So being very clear about what the robot can actually do. That's not. Wait, I had a case with those persona, but having a kind of like playful robot that knows it's a robot and it's kind of apologetic about what it can do. It can do presenting that, and mostly building use cases around what the robot can do, or ideally like building the robot around specific use cases. That's
okay. I'm thinking of one simple thing with Pepper. One has to know that you can only talk to the robot.
Yes.
It's blue.
Yes.
It has
Yes.
light on its shoulders and on the tablet, for example. And of course, if you know that, then it's easy. But normal people in their first engagement, they don't know it, and they just talk, and they are asking themselves why isn't the robot reacting?
Yeah, it's a good point. I actually hesitated on putting a slide around that. I ended up not putting one because I feel this is a bit like insider baseball on Pepper and very specific to like design decisions for Pepper that don't necessarily apply. And there have been some prototypes on doing like simultaneous listening and speaking. It's possible to do that kind of stuff with echo cancellation, etc. So some project worked on Pepper. So kind of it's almost like a technical problem. So it might be better to just find a technical solution rather than trying to find a design where you signify to the user, you teach the user how to do this. It's better to just actually solve the problem. But also making sure you have a design that actually signifies correctly when you can speak, when you cannot. Which I don't really have a good demo of here, but we've experienced it with a bunch of different stuff for that. But I feel like this is kind of like a band-aid. Ideally, you need to solve the problem as its root and make sure that the interaction just works.
Yeah. Okay. Thank you.
So, first of all, thanks again, Emile, for the great talk. Really.
Thank you.
Thanks.
Thank you.
Thanks for joining.
Bye.
See you guys next time.
Thank you.
Thank you.
Great to
Thank
see
you,
you,
Emile.
Emile.
Thanks for joining.
Bye.